At Disneyland, there's this Star Wars area called Galaxy's Edge, and when I visited the park last year, there's this one place I really wanted to check out. See, there's this place called the Droid Depot, where you can build your own R2-D2 or BB-8 droid, and I've always wanted to have my own R2-D2 droid, and during a trip to Disneyland, I was planning on getting one. But when I saw the price of $120, I was like, no thanks, I'm good. And as I saw people using their droids around the park, I knew that what I was getting for that price wasn't worth it, and that I could probably make a better R2 that has more features for even less. And so I made one. This is my version of R2-D2. It's a fully 3D printed 40% scale of R2-D2. It's basically a beefed up version of the one you can get at Disneyland. It's bigger, has moving holoprojectors, working periscopes, deployable grabber arms, more sound effects, and it's fully controlled with an Xbox controller. And this is how I made it. The first thing I needed to do was 3D print all of the parts I needed. I got all of the STL files from Michael Bradley's Patreon, which also has a bunch of different Star Wars droids that you can download and print. The printers I used were my modded Ender 3 and the Bamboo P1S, although I did use the Bamboo printer significantly more than the Ender, just because it's so much better. After everything finished printing, it was time to paint the prints. I used a tutorial from the channel 3D Printed Parts on how to paint and prep my prints, and it really helped. First, I used 80 grit sandpaper to knock down the larger layer lines and prep the surface for filler primer. The primer I'm using is the sandable filler primer from Ace, and its job is to fill in those remaining layer lines so we can get a much smoother finish overall. After the first coat of primer, you can already see that the print is a lot smoother, but there are still some layer lines that are showing through. So next, I sand it down even more and use a bit of spot putty to fill in the gaps that are too large for filler primer to handle. This is how the dome looks like after using the spot putty, and this is how it looks like after sanding it with 220 grit sandpaper. It's not really noticeable on the camera, but running my fingers over the dome, I can really feel how much smoother the surface is. From here, the process is pretty repetitive. We lay down another coat of filler primer, go back in with more Bondo spot putty to take care of any of the remaining low spots, and then sand everything smooth once again. This back and forth might not be the most exciting part, and honestly, it's really time consuming and annoying, but it's what really makes the difference in the final finish. And after one last round of sanding, we've hit the final coat of primer to even everything out. And at this point, the print is finally smooth, uniform, and ready for what actually matters, the paint. To start things off, I laid down a coat of silver paint, since most of R2's dome is silver. Once that was fully dried, I masked off the entire dome, leaving only sections that needed to be blue, and then sprayed those areas. After that, I covered the rest of the dome with a plastic bag, leaving just the front screen exposed so I could paint it blank. Once everything was dry and the masking came off, R2's dome was finally fully painted, and honestly, it looked really good. Now that all the painting is finished, it's time to move on to the electronics. This is the base of the dome. It's what the painted shell sits on, and it's also what holds all of the electronics. The first thing I installed on the base was the periscope assembly. It uses a small servo motor as a lever to push the periscope up and out through the top of the dome. Once that was mounted to the base, it was time to move on to the lighting. Using reference images from printedjoy.com, I was able to figure out exactly which areas of R2's dome needed to be illuminated. The LEDs are mounted onto these 3D printed inserts, which are then glued directly onto the dome. All of the LEDs connect to the 16-channel 12-bit PWM driver, which lets me control both the LEDs and multiple servo motors from a single board. Speaking of servos, the next assemblies were the 3 holoprojectors. Each holoprojector is made up of 5 printed parts and a single servo motor. They only took a few minutes each to assemble, and once finished, they were wired straight into the PWM driver. Finally, the dome is connected to the rest of the droid using a slip ring. A slip ring allows electrical connections to rotate continuously without the wires twisting or breaking. Installing it is actually pretty simple. The slip ring runs through the center of the dome, with each end soldered to separate PWM drivers, allowing the drone to spin freely while everything stays powered and controlled. And finally, after attaching the base to the dome and securing everything with screws, the dome is fully assembled and working. Next up is R2's body. After printing all of the body parts, the prep and paint process was basically the same as the dome, lots of sanding and filler primer, repeated until everything was smooth, followed by spray paint. The main difference this time was with some of the smaller details. Instead of masking everything off like I did on the dome, I hand painted a few areas, which honestly ended up being faster and easier. While painting the parts for the gripper arms, I ran into an issue where the added layers of paint made everything fit way too tightly. In this clip, I was applying so much pressure that I was genuinely worried that I was going to snap the arm. To fix that, I sanded off just enough material to give the arms proper clearance, and after that, they opened smoothly and without any issues. The gripper arms are assembled using 2 servo motors, one for each arm. A bent paper clip acts as a simple linkage between the servo and the arm, so when the servo rotates, it pulls the linkage and opens the gripper like a lever. The servo motors are then connected to the same PWM servo driver that is connected to the dome via the slip ring. In this clip, you can also see me using an Xbox controller to open and close the gripper arms. The controller is connected to a Raspberry Pi Pico W, which reads the inputs and then sends commands out to multiple boards, one of those being a DF Player Mini. The DF Player Mini is a small, low-cost MP3 player module that can play audio files directly from a micro SD card. The other board the Pico is connected to is an Arduino Nano, which is essentially a smaller version of the Arduino Uno. The Nano communicates with the Raspberry Pi Pico over I2C, receiving controller inputs and translating them into R2's actual movements and actions. Here you can see all 3 boards working together, the Raspberry Pi Pico W, the DF Player Mini, and the Arduino Nano. You also notice these 2 red boards connected to the Nano. Those are the motor drivers, and they're responsible for controlling the DC motors that move R2 around. The blue and yellow wires running upwards connect to the PWM servo driver, which allows the controller to operate things like the gripper arms and the periscope. Changing gears a bit, this part here is the skirt that sits at the bottom of R2. It attaches to the base of the body using a few nuts and screws. Inside the base is the mechanism for the deployable third leg, which uses a servo motor. I did build it, and it does work, but I decided to keep that feature inactive for now, mainly because the amount of wiring made deployment and retraction pretty unreliable. The main electronics board is also mounted to the side of the base using double-sided tape. This ends up creating a pretty messy looking module, which will eventually slide into the body from underneath. But before any of that goes in, I need to attach the legs. After sanding, priming, and painting, the legs and feet were finally ready for assembly. The first step was to put the wheels together. Each foot uses 2 different types of wheels, an Omni wheel and a standard drive wheel. The Omni wheel is a fully 3D printed wheel made up of several parts. Each roller slides onto a small piece of wire, which acts like an axle, and then gets glued onto the base of the wheel. I didn't have any wire that was both thin and strong enough, so I ended up using solder wire instead. And surprisingly, it's been working just fine. I repeated the process for the other half of the Omni wheel and then screwed the 2 halves together. The second wheel type is much simpler, with just 2 parts, the wheel itself and the flexible tire printed in TPU. The issue I ran into was that the tire didn't want to stretch over the wheelbase, so I had to do what I had to do. And gluing the tire back together, it fit perfectly, and I was good to go. Once the DC motor is attached and screwed into place, I can route the motor wires through the leg and secure the leg assembly. From there, I attach the 2 wheels, close everything up by screwing the other half of the foot, and just like that, one leg is fully assembled and complete. For the third leg, I start by slotting and gluing 2 bearings into the wheel wells, and then snap in the 2 3D printed caster wheels. And with that, the third leg is fully in place and ready. Now I can finally attach the 2 main legs to the body. I start by routing all the motor wires up into the body, carefully lining everything up, and then screwing the first leg into place, then repeating the process for the second one. Once both legs were attached, R2 was really starting to take shape. And now, it's time for the final assembly. I start by sliding the entire electronics module into the body from underneath. This part was way harder than I expected, mostly because of the sheer number of wires that kept getting caught or tangled, but after a lot of patience, everything finally slotted into place. Once the body was secured and screwed down, I mounted the DC motor on top, which allows the dome to spin. The grabber arm assembly is friction fit into position and then connected to the PWM servo driver. The servo driver is then soldered onto the slip ring wires, and then the dome can be slotted on top. Finally, I glue in the front grille plate, and R2 is complete. If you're interested, all of the code, electrical schematics, and documentation are in my R2-D2 repository on my GitHub. I genuinely thought I managed to build a better version than the one that you can buy at Disneyland, and for less money too. Never mind!